haven't or are going to watch the catch-up recording of, though we do have a really great number live, which is what we like, in case they might have been a prize winner from research assignment prizes. And first of all, I want to say just well done to everybody. Awesome effort. Great content came in. Lots of good technical info came in. There was also some really entertaining stuff that came in. So I was, just loving it all. So some prizes. So first of all, I'm going to give out some sort of, I suppose I'll call them noteworthy prizes. So these are for ones that I either just found funny for some reason, or I thought they'd done something nice and put something together nicely, and I wanted to, give them a noteworthy prize. So Tim gets one for filming the absolute chaos of lockdown 6 and video on roundabouts, traffic signals, where there were dogs and kids appearing and all sorts of chaos. I thought it was hilarious. So a noteworthy prize there. Matt Welsh for his WB Ben Terminals sheet, which was just really well put together, I thought. Adrian for motorcycles at roundabouts, a great sort of presentation along there, and sort of very noteworthy because it noted some of my referenced some of my research, which was enjoyable to see. Damien's Ice Baby Y intersections gets a noteworthy award. Gave me a good chuckle. So there's a few noteworthy ones, but into the major prizes here. So for the engaging, we are going with Sarah's cat video for retro reflectivity, and Julian's dynamic visual obstruction. So utilizing Simpsons episodes to explain what dynamic visual obstruction is. So that's our creative. So, or is that engaging? Anyway, it doesn't matter. The other one is, so we've got Shanna for self-explaining roads. A great little video there on how to what a self-explaining road is. Lots of awesome info and lots of little snippets of entertainment in there as well with the road safety side of the force. And Cynthia for the heavy vehicles at roundabouts, another great presentation / video put together explaining that. And for technical accuracy, Russell for his Dilemma Zone whiteboard teaching session, beautifully technically accurate, went with explain type 1 and type 2 dilemma zones, so they're stepping up into the next level. And Zidong for the cyclists at roundabouts, so some great information about cyclist treatments and roundabouts, the risks and how we need to think of those. I reckon most if not all of you could have got a prize. You had a great effort there. I gave out lots of full marks there, so well done to everybody, but lots of opportunities still to come for chances to win prizes. But thank you very much for your efforts on those. If you have, there's only 1 or 2 people I think who haven't quite yet got their assignments in, so please do that. Okay, this session we're covering off some road design, road safety audits, and technical end stuff. Also integrating a bit of heavy vehicle thinking in there. So a road user we haven't had a lot of focus on yet in our road safety thinking. And we've got Jamie Robinson joining us. Jamie is the technical lead at Safe System Solutions, works alongside me. We audit together a lot, and it's certainly always great to have somebody with a wealth of technical, very technical end experience auditing, and we enjoy that. So I'm going to get Jamie to just share your slides there, Jamie, for now, and I'll do a quick intro and then hand over to you. After Jamie, we've got Tony Bull coming in, who's going to briefly talk about construction site road safety audits, so those road safety audits of traffic management schemes and the like. And then I'll finish it off with a little bit on checklists and giving you another assignment, although this one's not. Although this one is not as big as, well, yeah, it should be a fairly quick one. It's desktop exercise. But this module, we want to differentiate between standards, reviews, and road safety audits. So Jamie will explain more about that, understand the difference between design vehicles, checking vehicles, common issues with swept path diagrams, site distance, different site distances and how we think about those, and issues in detailed design audits. Difference between, and then when we get to Tony, it's the difference between compliance audits and road safety audits in those traffic management plan, guidance schemes, construction sites, and some of the issues we'd look for as auditors at construction sites. So jump on to the next slide there, Jamie, and I'll very briefly introduce you. So as mentioned, Jamie's technical lead with us at Safe System Solutions, is a specialist in road safety barriers, and some design stuff, traffic engineering, runs quite a number of courses, safe system assessments, and has been auditing for 15 years at least, I reckon. And yeah, so Jamie's contact details are there. So if anything we don't get to that you want to ask Jamie about, please get in contact with him. He's always willing and in fact happy to have a chat and provide you with info on different things. But for now, I'll just hand it over to Jamie. But please keep your questions coming in as we go, and we'll jump in and stop Jamie as he's ticking along. Over to you, Jamie.
Thanks, Ken. Morning, everyone. And yeah, please do keep the questions coming in through the chat. I'd like to start off by having a chat about the difference between a standards review or a design review and a road safety audit. Often we're asked to provide quotes for one or the other, and often the client's not quite sure what they need. There certainly is an overlap between the processes, but a standards review, as the name suggests, is purely focused on standards. Now, there's an inherent level of safety in standards. They do lead to safer outcomes. They promote consistency of design across the network, and therefore, a certain level of road user expectation and familiarity with our road environment, and are therefore safer. A road safety audit, however, the focus really is on achieving safety and eliminating safety risks. So that's what your focus is when you're doing a road safety audit. Any road project brings together any number of different road design elements. Each of those have a range of acceptable values from desirable down to minimum. And it really is when you're combining minimum standards on a project that you do get into trouble when it comes to safety. So a road safety auditor really needs to be able to put themselves in the position of the road users that are expected to use the intersection or the piece of road, and imagine how they'll interact with the other road users and with the various design elements. And really think about the potential safety issues that you might encounter. Something designed in accordance with standards may be safe, but it may not. Conversely, something that's not designed to standard isn't necessarily unsafe. So really think about the potential for safety issues. So you're doing a design stage road safety audit, and the focus of this presentation is on heavy vehicles as well, for a couple of reasons. That's because heavy vehicles are the largest vehicles that you expect to use your piece of road, and they therefore dictate a lot of the design elements. And probably a secondary reason is that heavy vehicles are highly overrepresented in crash statistics, just simply due to their size and mass. When they are involved in crashes, the impact energy is such that there's much more likely to be serious outcomes, in addition to the other issues that they have with poorer deceleration, sight distance issues, and so on. So we're doing our road design, our design stage safety audit. You've received a set of drawings. In addition to that, you may receive some other information, or you may want to request that from your client. It is important to understand the design vehicle on which the design is based. Now, the design vehicle, for those that don't know, is the largest vehicle that's expected to use the road or intersection on a regular basis. A couple of typical examples there are a service vehicle, which might be a garbage truck in a local road environment, up to a B double or an even larger truck on perhaps on an arterial road. The speed environment, together with the design vehicle, or the design speed, I should say, together with the design vehicle, does dictate a lot of those key design elements. So it's important to understand what speed the road has been designed to. Now, that speed isn't necessarily the same as the posted speed limit. In rural environments, it's typical to adopt a design speed that's higher, perhaps 10 kilometres higher than the intended posted speed. And that's because we know that 85th percentile speeds on rural roads typically are in excess of the speed limit. Vehicle swept path diagrams may be provided. If they're not, and you think that there might be an issue associated with vehicle swept paths, please do ask for those from your client. And if they can't readily provide those, that's a real red flag. Vehicle swept path checks should be undertaken as an integral part of the design process. Traffic data, vehicles, pedestrians and cyclists. It's good to know how many and what type of each of those users are present at a particular site, so that you can think about the allocation of space to different road users, priorities, and so on. Crash history at the site. We've got a little comment there that crash history really shouldn't drive a road safety audit, and that's because there really is quite a randomness to the locations at which crashes occur. So certainly single crashes should be treated with caution. If there's a trend of crashes, that's another matter. But when you're doing an audit, you really want to make sure that you don't have the blinkers on and be focused solely on crashes that have happened in the past. If audits have been undertaken at previous design stages, it's good to have those in hand so that you can tick off issues that have been addressed, consider whether you think other issues are still present. If it's been done by someone else, it's a good learning experience to see how a different auditor has viewed the project before you. So I guess the moral of this slide is to seek any information from the client that you think would be useful to help you understand the context of a project and how the design has been arrived at. A few common issues that me and my colleagues have come across in doing the audits that we do. A lot of those relate to the choice of design vehicle and providing enough space, or perhaps even too much space, for vehicles. So a design may not adequately cater for the swept paths of the design vehicle, or the choice of that design vehicle might be incorrect in the first place. If the choice of vehicle is too small, it's likely that larger vehicles may encroach into areas that they shouldn't, perhaps mount curbs, adjacent traffic lanes, and so on. If the choice of design vehicle is too large, you might result in excessive areas of pavement, which mean that smaller vehicles can cut corners and travel at excessive speeds. So we have encroachment into adjacent traffic lanes. I'll show you some examples of some of these things shortly with some photos. Heavy vehicles often do encroach into pedestrian areas where they're not adequately catered for. And we do unfortunately see on the news sometimes where pedestrians standing at the corners of intersections have been struck by turning trucks. Vehicle conflicts within intersections occur when there perhaps isn't enough space for concurrent turning movements, perhaps right turns from opposing directions. And a telltale sign of there not being enough space is impacts with roadside furniture, signs, curbs, curb damage perhaps. So there are some things that you can really keep your eyes peeled for out on site when you're doing audits at the design stage. I say out on site, most design stage audits are upgrades of existing roads. So it is possible to get out on site and get your head around the existing conditions and think about how things might look when the proposed changes have been implemented. The Austroads guides provide a lot of detail on swept path requirements, clearances between turning vehicles. So a couple of snips there, one from the Austroads guide on the left. On the right, we have a snip from the Austroads turning template guide. And that looks to be a semi-trailer. So for each possible design vehicle, there is a series of swept path diagrams like this that you can refer to that show the amount of space that a turning vehicle will take up at a certain radius and speed. So this one looks to be, I don't expect you to be able to read it, but this is a semi-trailer at a 20-metre turn radius, which correlates to a turning speed in the order of 15 to 20 kilometres per hour. We can wind things back, particularly at mandatory stop situations, so a stop sign where a vehicle is expected to be turning very slowly. They can do so on a minimum radius, but their swept path is likely to be wider again. Now we have these templates in the Austroads guide, but the way that these are produced these days is using computer software like AutoTurn. So you'll likely receive your swept paths sort of electronically or in PDF as part of a design package. Here's an example of a swept path diagram that's been generated using AutoTurn. You can see a truck from the right, turning right from the right, shown in purple, and one from the left in blue. There's lots going on there with different line types and things. You can turn on and off lines that represent different things in AutoTurn. The lines here represent the outer extremities of the turning vehicle. Some of the dash lines appear to be the wheel paths. We also have on the outside a parallel line on the outside, which is a clearance. And in accordance with the Austroads guides, we need a 1/2 metre clearance between the vehicle body and roadside features such as curbs, signs, and so on. So it's typical to show that parallel line to demonstrate that the required clearances are being met. Another thing that I'll point out here is a number of little arrowheads. You might see on the purple one in particular, arrowhead, here and here. That rings alarm bells. Each of those arrowheads represents, I suppose, a decision point, a change in direction by the driver. So the swept path in purple is far from what you would expect a truck driver to do if they encountered this intersection and they weren't familiar with it. They would likely try and drive through on a single radius in the same way that they had done at every other intersection of this type that they'd encountered recently. So at first glance, this swept path diagram might appear to be okay because we do have a clearance between those opposing trucks in the middle here, you can see. They're missing each other, but had this truck in purple in particular been drawn in the correct way, there'd be quite an overlap. So keep your eyes peeled for those arrowheads. We want to see a single radius that accords with the Austroad's guidance for any turn by a truck. Yeah, so look, it is something that is quite easy to fudge, and unfortunately some designers choose to do so. This clearly is a very constrained environment. You can see that the intersection is very close to the right-of-way boundary at a number of points, so it appears that an intersection has been drawn within the available space, and an attempt has been made to make it look like the required turn movements can occur. So there certainly is a safety issue associated with that lack of space, although you wouldn't expect two truck drivers to continue forward into a collision situation. Someone's going to take evasive action or put on the brakes, but those actions in themselves might lead to safety issues, rear end crashes perhaps. If the truck does take evasive action, they might encroach an opposing traffic lane with potential for a conflict with the vehicle there. So in assessing the risk of an issue like this, you really need to think about the likelihood of two trucks of this size arriving at the same time. If you have traffic volume information, you can do some thinking about that. It could be the case that the choice of design vehicle isn't correct, or that the likelihood of this situation happening is so rare that you don't consider it to be much of a risk. You could address this risk, or at least mitigate this risk, by through your signal phasing, controlling movement so that this conflict in theory shouldn't occur. A standards review type finding at this location might be along the lines of the conduits between the signal pits isn't contained within the right-of-way boundary, which is certainly a no-no. Here is a better example of a swept path diagram. I say better because these swept paths have been drawn on a single radius. They're transparent because the radius is nominated on the design. You can see a 12.5 metre radius for the bus turning in and out of this location. This is actually a location that, or a design that we inherited at Safe System Solutions. Some swept paths had been prepared, suggesting that these vehicles could get around these corners without encroaching any areas they shouldn't. We did our own checks, which showed that those vehicles can't, and that just goes to show that there are some different practices in the industry, perhaps some misunderstanding about how to construct these diagrams, and it is important to know what you're looking at. You can see here with the blue bus rather, at this corner of the intersection, there's a significant encroachment behind curb into a pedestrian area, and a potential risk, therefore, to pedestrians waiting to cross at that location. If we look to some other movements, you can see some overlap between some turning movements that would be allowed to occur concurrently. So potential for crashes like side swipes, perhaps some minor head-ons there, or some issues associated with evasive action. So you really do want to see those single radius turns And that's because drivers often aren't familiar with the locations that they're turning at. So we're really designing for those drivers. A driver that knows a location and knows that it's tight and they have to do something out of the ordinary can do so. So turns can be made in this way, but it's not going to be the expectation of an unfamiliar driver to have to do this. So we want to provide, I guess, a conservative design where a driver can take a generous radius consistent with other intersections on the network. There's one of those telltale signs that perhaps there isn't enough space for a turning truck. You can see trucks have encroached, or presumably trucks or larger vehicles have encroached behind the curb. You can see the wheel tracks, perhaps a little bit of braking at the back of the curb. So that may well be a sign that there isn't enough space for large vehicles to turn here. It could be pointed to some other issues, perhaps excessive speed. Here we can see some encroachment behind curb again, and over a pedestrian crossing point, you can see the wheel tracks encroaching a significant distance onto this raised island. I think the main issue here is the lack of contrast between the island and the road pavement, the concrete pavement. I've also had it suggested to me that this location in the Port of Melbourne has an issue with excessive speed. So it's not necessarily that there is a lack of space for heavy vehicles. There might be other things at play, a lack of delineation or speed issues. A pedestrian waiting at this point here may be at risk of a strike from a vehicle that chooses to encroach this area. It's probably more so a pedestrian on the other side of the road is at risk, and that's because of the cut-in effect when longer vehicles, and particularly articulated vehicles, turn. The rear wheels cut in and take a shorter path than the front wheels, which can result in those rear wheels being offset a significant distance, a number of metres from the front wheels of the vehicle. And it can be difficult for the driver to understand where the rear of their vehicle will end up. So a person on this side of the road, I would argue, is at a much greater risk than a person on this side of the road, where the driver would likely see them in their path. Knockdown signs is something that you frequently see on the network, and it is another telltale sign that there may not be enough space for turning vehicles. In itself, is perhaps not a big deal. The sign can be stood up again. But in the meantime, if it's an important sign, other road users may not be alert to the situation or the hazard, the potential hazard. If the driver instead chooses to take a different path to avoid the sign, they might find themselves encroaching in an area that they shouldn't. So there are some issues there. Probably the most common example of knockdown signs that I encounter is keep left signs on splitter islands. In those situations, you can use frangible posts that will rebound and live to see another day, but they really are, that really is a telltale sign that there perhaps is an issue with lack of space for heavy vehicles. I might just step back there. I realised that I've been talking about design vehicles and choice of design vehicle, but I haven't touched on the concept of a checking vehicle. Many of you may have heard that term. In designing roads, we typically use that design vehicle, that largest vehicle, typically a truck that will use the road on a regular basis. In addition, we like to check our designs using what we call a checking vehicle. That's a larger vehicle, again, that might come along once in a while. but we do need that vehicle to be able to navigate the road or the intersection. A design vehicle needs to be able to get around and use intersections in a desirable way. So that might mean turning left from within a left turn lane if one is provided, not mounting curbs, not swinging out into across the road in order to make a turn. A checking vehicle is typically permitted to do those things, and that's due to the infrequent movement of those vehicles, and they're perhaps under escort when they do come along. So we're talking particularly big trucks often. So it's typical to see checks for a design vehicle and a checking vehicle. I hope that makes sense.
And Jamie, as a road safety auditor, how do you know what the design vehicle and the checking vehicle are for the design that's presented to you to audit?
It's likely to be documented in a design report. Look, it depends on the project. If it's a larger project, you're likely to receive a design report that spells out the choice of design and checking vehicles. You might be able to determine it from swept path diagrams if they're provided. If it's not evident, you really must determine that or ask your client what the design and checking vehicles are for that particular project.
Thanks.
So please fire through any questions, especially around swept paths, design vehicles, checking vehicles. And we'll move on to sightline issues. But please do keep those questions coming. So with regard to sight distance, it's often the case that a design may not provide adequate sight distance. There is a list of sight distance requirements as long as your arm. Not all of those apply to every roadworks project. So you need to think about what road users are present to determine which and what is your arrangement that you're auditing, determine which of those requirements apply. There are sight distance requirements between vehicles, vehicle to vehicle, typically measured from a driver eye height to some part of an oncoming vehicle or an approaching vehicle, to other road users, perhaps pedestrians at pedestrian crossing points, sight distance requirements to the pavement. And there are a range of things that can restrict sight distance requirements out on the ground. The road alignment, horizontal and vertical curves, in particular. Horizontal curves with trees or other obstructions on the inside of curves can limit sight distance to an intersection downstream, perhaps to the pavement, so that you don't have enough time and distance to brake before striking something that may be on the road. Vertical curves as well can limit sight distance. Crests we're talking about. And when you combine horizontal curves and crests, you really can be asking for trouble in terms of sight distance restrictions and also increasing the likelihood of run-off road crashes. We know that the frequency of those type of crashes increases at horizontal and vertical curves, and when you're combining the two, the risk is compounded. Visibility can also be restricted by parked vehicles and other obstructions near intersections in particular. Parked vehicles is an interesting one. There's an argument that a parked vehicle is a temporary obstruction, and often people don't consider that. The parked vehicles should be considered as part of sightline checks. I don't know how many audits I've done that have come about because of issues associated with vehicles parked near intersections. So they certainly do compromise sight distance and contribute significantly to crashes at intersections. Road furniture, poles and trees and so on near intersection corners in particular can really impede sight distance. Vehicle stand-up angles at intersections. By that I mean the angle at which you approach an intersecting road the desirable situation is for a vehicle to approach at a right angle or as close to a right angle as possible to allow you to see easily in either direction to approaching traffic. It's where we're getting acute stand-up angles. We talk about Y intersections and their high crash rates. That's where we really do see trouble. It is difficult for drivers, and particularly elderly and sort of mobility impaired drivers, to look back over their shoulder and see approaching traffic. And there often is a failure to give way problem. One of the sight distance requirements spelt out in the Austroads guides is SISD, and perhaps, Ken, we can give a little prize for the first person to tell us what SISD stands for.
Sure, Jamie, and we do have a few questions in about swept paths and things, so we'll see who gets SISD first, and then we will. JY Chong has got there. Oh no, well. So we're going to give it to Damo and JY Chong there, pretty much at the same time. So prize for both of them, Emma. And Tim almost had it, but got the slight wording wrong. So the questions that have come in, Jamie, a few of them. So one of them is, do you put the design and checking vehicle onto the plans in a design, a road design, traffic design? Do you actually write that anywhere?
Perhaps on a swept path check plan, not on your sort of primary design plans. You wouldn't typically see that, but if you have some swept path diagrams, some swept path check plans, you would see it's typical for a designer to put an image of the vehicle on the plan, or to note what the design or checking vehicle is in some general notes.
Yeah, and they usually use the Austroads, whatever it is, design the vehicle classes or whatever they are.
That's right. So Austroads, there is a list of about half a dozen sort of typical design vehicles or reference vehicles. Now they're sort of, and those being a service vehicle, sort of up to a single unit truck, a longer truck or bus, semi-trailer and a B double. And the design vehicle, each of those design vehicles is given a particular length. Now, all vehicles in each of those categories certainly aren't exactly those lengths, but those lengths are at the upper end of each of those categories. And by using that design vehicle, it's considered to represent all vehicles of that type.
Yep. Another question has come in around the idea that you might design an intersection or access or the like for smaller vehicles, but during the construction phase, so if this is a subdivision or something, larger vehicles use it for that period of time. And if the designs change, if you change the design in order to accommodate those larger construction vehicles, it could compromise things into the future. Do you have any comments on that?
Yeah, look, there are things. Yeah, look, you need to look to the future when you're choosing your design vehicle. So you need to be mindful of potential changes in land use in the vicinity, and that might mean that you consider a larger vehicle. But if you're only expecting those large vehicles to be present during construction, you wouldn't want to design your road or intersection sort of in a permanent way to cater to those. But there are things that you might do to allow them sort of safe passage during construction, and that might be paving areas behind curb or locating your signs so they're not struck by those vehicles. You might have traffic management in place to help those vehicles get around and manage conflicts. So you do want to avoid designing an intersection based on a vehicle that is too large if you're not expecting that vehicle to continue to use it. that will result in excessive areas of pavement and some potential safety issues.
Yeah, good. Okay. And the last one, just somebody pointing out that they're working with designs in the like of road safety barriers, and they're solving some issues with those, the runoff road risk, obviously, but potentially creating other issues with sightline impediments from the barriers. Now, I know this is one of Jamie's sort of passions, road safety barriers, and he runs a 3-day training course on barrier design and the like. So we're not going to let you talk for 3 days on this, Jamie, but just a quick insight into that from a road safety auditor's perspective, really. Maybe a road safety project, so it's improving things, but maybe causing some other issues.
Yeah, it is a frequent thing with all the barriers that have been retrofitted around the place. We are seeing some barriers put in that do create sight distance issues. Often the designer makes the assumption that you can see over these barriers. If everything's sort of flat and level, you typically can, but it's where a side road or a driveway ramps up to meet the main road, or perhaps there's a crest or a curve in the main road, that a barrier can impede sight lines. If we're locating our barrier at a desirable offset, 3 or 4 metres, you can typically see in front of the barrier, so you don't have any concern. It's where we're locating a barrier closer to the road than 3 metres, typically, that we see those issues. Sometimes we do need to shorten barriers up to avoid impacting sight lines. Sometimes, and where we can, we should try and flare approach terminals away from the road to open up sight lines. That can also improve things in terms of space for swept paths into side roads. So yeah, really do be mindful. Some of the newer barriers are higher, greater in height than ones that we've used previously, the new wire ropes especially. So don't assume that you can see over barriers. And wherever possible, we'll get that 3 metre or more offset for sight distance reasons and other reasons.
Yeah, and for me, it's I suppose a reminder that so even a road safety project, which is it's fully aimed at improving safety, needs to have road safety audits done because it can bring up other road safety issues that either hadn't been thought about or been generated as a result of different things. So if somebody says to you, "Oh, we don't need road safety audits on this program because it's a road safety program," you say, that's not the case. You really should be doing that independent audit on all infrastructure projects of a certain size or certain risk profile. Thanks, Jamie. That answers those questions, but do keep the questions coming in.
So back to SISD, safe intersection sight distance is one of our sight distance requirements, and it applies at intersections. It provides enough time and space for a driver on the main line to see a vehicle from the side road enter an intersection, perhaps stall in the middle of the road. This guy needs to react to that situation, put on the brakes and come to a stop before reaching that point. So your SISD requirements can be quite onerous. In a high-speed environment, 100 Ks, we're talking something like 260 metres, I think. Another thing I'll point out from this diagram is the location at which SISD is measured to on the side road, 5 metres setback or 3 metres minimum. This just reminds me of the need to consult your state-specific supplements to the Austroads Guide. The Vic Roads supplement says something a little different, which accounts for the possibility that there's that the hold line setback, there might be a left turn lane approaching the intersection, which means that the hold line is set back. So it talks about the distance, the setback from the conflict point rather than the hold line. So always look to, if you're looking up a standard or an Austroads guide in particular. Consult the VicRoads supplements to those guides because they do take precedence, and sometimes it's some local practice that you might not be aware of. For SISD, you must look in the horizontal and vertical plane. You can see here that any objects, including parked vehicles, trees and poles, near the corner of the intersection can impede SISD. A vertical crest, if it's at a sufficient K value, will restrict SISD to below acceptable levels. Another key difference between many of the sight distance requirements is the distance from and to which that requirement is measured. You can see here with SISD, it's measured from a driver eye height to the top of a car. Often we're measuring from a driver eye to the pavement, or perhaps an object on the pavement, or perhaps even to the tail lights of the vehicle in front. It depends which of your sight distance requirements you're dealing with. And the Austroads guides, part 3 and 4, spell them out in a lot of detail. This is an example of a project where parking was formalised in the vicinity of an intersection. We had a road with a wide carriageway, and because of its width, it was actually functioning as a 4-lane road in congested or in sort of peak conditions. It wasn't marked in that way, but its width was sufficient that it could. So to deter that behaviour and formalise parking, some line marking treatments were implemented. You can see the solid yellow lines there up to the intersection, or 10 metres from the intersection as per guidelines, was installed to allow parking. This project was put in place, and you can see the result. Some vehicles parked about 10 metres back from the intersection. Problems quickly arose with intersection type crashes at this location. You can see that sight lines from the driver on the side road are significantly impeded by parked vehicles here. And you can imagine if the vehicle at the front was a van or a small truck or something, the situation would be worse again. So a problem of intersection type crashes presented pretty quickly. And this really is a typical black spot type project where we have a trend of crashes of this type. And we're talking side impact crashes, which even at relatively low speeds can result in serious outcomes. So I put it out to you guys, what could we do here to improve the situation again? Send your thoughts through to the chat, please.
Sorry, Jamie, just lost my unmute button there. Right, here we go. Let's see what people are saying. Okay, we've got some people who want to remove car parking to open up those sight lines. That would certainly do that. Push the giveaway line forward. Curb out stands. Reduce the speed.
Like it. Let's do all of those things. Removing a couple of parks clearly would help and perhaps be an initial fix. I like pushing out the hold line. That, along with some curb out stands to shelter vehicles on the side road, would be the ideal situation. How far out we can push that hold line would sort of depend on our lane widths, whether we thought we needed to provide some space for cyclists. We don't want to create a pinch point for cyclists, for instance. But ideally, we might push the hold line out to this continuity line, which would give motorists on the side road a clear view of approaching traffic forward of parked vehicles. If we constructed a curb out stand through here, we would be losing at least a couple of parks and removing that sight distance obstruction. We'd be improving the pedestrian crossing situation here as well. Reducing the speed limit, or perhaps changing from a give way to a stop sign is perhaps something else that is sometimes considered that might help. But the preferred situation would be to really open up those sight lines by bringing that hold line forward.
Yeah, we also had some bigger treatments like signalising the intersection and those as well.
So I mentioned that there is a whole range of different sight distance requirements. A key difference between a number of these is the observation height, or the height that we're observing to. Stopping sight distance is measured to an object of an assumed height of 0.2 metres on the road. Approach sight distance to the pavement, and approach sight distance is something that we particularly provide on the approaches to intersections, so that you can see intersection pavement markings, turn arrows and the like. Stopping sight distance should be provided at any point on a road. Entering sight distance really is a luxury that is intended to provide enough time and space for a vehicle to enter from a side road so that it doesn't impede or slow vehicles on the main line. So that's something that's probably rarely achieved. There are lots of others, many that aren't even on that list, such as pedestrian sight distance. So I do encourage you to look to the Austroads guides if you are undertaking an audit and you think that there might be a sight distance issue. Sort of raise that issue in your report from a road user perspective, and then if you can back it up by quoting a guideline, that really does give it some weight. Just briefly wanted to touch on rural and remote roads, which are commonly unsealed. And you can see an example there, which has a particularly straight alignment. They're often sort of long, uninterrupted sections of road. A key issue on these roads, or a key consideration, is to delineate features that are out of the ordinary, if and when you do encounter a curve, to provide good advance warning of that. Provide guideposts and these type of things. They're such low volume roads that it's not feasible to be providing the Rolls-Royce treatments that we might like to provide elsewhere, such as safety barriers. So it's really about maintaining the road surface as best we can and providing lower cost delineation treatments, particularly to alert drivers to higher risk features such as curves, crests and dips and so on. There's a list of common road safety audit issues found at intersections. Now, these and others are listed in the checklists at the back of the Austroads guide for road safety audit. I do encourage you to use those checklists, especially if you're new to auditing. They're a really good ready reference. Not all of these issues will apply to every project, far from it. But it is useful to check them off and make sure that you're not missing anything. So you might have the appropriate list in your back pocket when you're getting out on site to do an audit. There is a different list for design stage audits, existing conditions, pre-opening audits. Each audit stage has its own list. So at intersections, we really are looking at those things like choice of design vehicle, swept paths, sight distance issues, delineation of intersections, We really do ramp things up. We have some intersection specific things, especially where we have turn lanes and so on. Look, I won't go through each of these in any detail, but if any of these sort of strike a bell with you, please yell out and I can elaborate on any of them.
Thanks, Jamie. Nothing in yet. A few people had these as their assignment research topics where they provided a fact sheet or a video or the like. So some people are quite aware of them, but there are many things out there to try to get your head around and to be aware of as an auditor. But we'll see if anybody does want to point any of those out. I should have mentioned earlier that and that with those assignments, we are hoping we are going to upload them to Moodle so others can have a look at the assignments and get their head around these topics with a fact sheet or a little video or the like. So we do plan to share all of those. If you really don't want yours shared, just tell Emma. But I think they all add a little bit of value and a little bit of entertaining viewing and a way to understand something like, well, what is a Danish offset as has just been asked there. And there is actually a fact sheet on Danish offset that's available, but I'll get Jamie to briefly explain what a Danish offset or Z crossing is.
So Danish offset is something that we provide pedestrian crossings of divided roads. So it's an offset within the median of the road, and the direction is important. We want pedestrians across the first carriageway to then turn such that they're facing traffic approaching on the next carriageway. So you sort of want a left-right stagger within the median to have pedestrians facing traffic. I hope that makes sense.
Yeah, I think you explained it well. You could probably draw it on your there on your PowerPoint. If you go down to the bottom, there's a little pen.
Okay.
Yeah, you got it.
Right.
There we go.
Yeah, here we go.
There we go.
This is the median of our road. We have a crossing here. Within the median, we want our footpath to look something like this. And then we have our crossing point on our other carriageway.
Yeah.
We have traffic coming this way here and this way here. So our pedestrian that dawdles along here enters the median, turns this way, and they're looking towards oncoming traffic. If the situation was reversed, there'd be an increased likelihood that someone would simply, if they're in a hurry especially, head across to the other carriageway, not even look to oncoming traffic before they step onto the road.
Very good. Stamp that issued for construction, Jamie. Ready to go.
How do I get rid of that?
It's a common one that it's just the one way around, and it's it's certainly just sort of something that can be altered. Sometimes there's physical constraints, meaning that it can't be done, but that way around. Good question. Any others there?
All of these issues are really about managing the likelihood or the severity of conflicts between different users at intersections. So it's important to think about who will be using the intersection. Are there pedestrians and cyclists present? What space is allocated to them, crossing treatments, and so on. We really want to minimise the number of conflict points and provide treatments that manage speeds to tolerable levels at those conflict points where we can.
Great. And Tony's arrived, so all ticking along well. And what have you got on the one slide?
Ken, I was just going to add to, and it'll probably lead into my little spiel. I'm not taking over from you, Jamie. G'day, Ken. G'day, Jamie. But it's an interesting one, that one you've just depicted. It's when we go to a construction mode that we actually maybe do a contraflow. So therefore, all of a sudden, those pedestrians who cross that every day, they look to their right, they get to the other way, they look to the left and the like. So it forces them to, but when we do contraflow, we might have two-way traffic on that one-way road. All of a sudden that habit is, so we need to sign that accordingly as well. So, when we change permanent conditions, we need to make sure we sign it in a way that people will adjust to the new conditions for road construction.
Good, thanks, Tony. Yeah, contextualizing. It's all about contextualizing these issues, isn't it? What are the circumstances?
Yep.
Thank you. Good input. Jamie, I think you got maybe one more slide, but a question came in, bike box location. Is there an area where bikes queue? Not sure I fully understand your question there. Was that one of the... Oh, sorry. It's
right.
bike box. Explain bike box location. Or do you want me to run that one?
I'm happy to. By bike boxes there, we're talking about head start storage areas at traffic signals. So you sometimes see, well, where there's a bike lane and sometimes where there's not. You see a box with a bike symbol located forward of the hold line. So that provides a space for cyclists to store in so that they're forward of traffic, they're visible. But it's sometimes the case that turning vehicles might conflict with bikes that are waiting in those areas. So that can come down to managing the signal phasing to avoid that situation, or modifying our layout to ensure that doesn't happen in the first place.
Yep. Great. Thanks, Jamie. And I think you're on to your...
So one more slide. So the previous slide was about issues at intersections. This one's about mid-block issues. So the focus is a little different. We don't have those same vehicle-to-vehicle or road user-to-road user conflict points. At mid-block locations, it's more about the cross-section that we're looking to provide, providing space for the road users that we need to. That might be a bike path or a shared path. Designing our roadsides to avoid run-off road crashes. So that might be to do with our choice of batter slopes. Do we provide safety barriers? What drainage treatments do we provide, and so on. So the thinking is a little different at mid-block locations. It's more about run-off road crashes, perhaps cross carriageway crashes, and delineation treatments to mitigate those risks.
Good. Thanks, Jamie. And I'm going to go through, explain a little bit about those checklists, expand on that a little bit more and point people at where they can find it. Prompt lists, as we're calling them, in the next update to the Austroads Guide. And Tony will also, I think, mention those near the end of his presentation coming up. But thank you very much, Jamie. Appreciate your time. And of course, as mentioned before, Jamie's contact details at the start of that presentation. So if anybody did want to follow up with Jamie on any questions there, please do contact him, or of course you can contact him through myself or Emma. Thanks, Jamie.
Cheerio.
Okay, now we're going to, we'll give you 2 minutes, just have a stretch. Well, before we get Tony up and running, I'll introduce Tony in 2 minutes. And while you're having a stretch there and filling up your water glass or whatever, we'll just make sure Tony can share his slides, and hopefully we might get a camera maybe of Tony, but he might not have that going today. Again there, please, Emma. And we'll introduce Tony, and maybe Tony, you just pop on to the next slide there for me for a little bit of an introduction, and then you can fill in any other gaps. But Tony Bull, who some of you may know because he's been a leader in Victoria in construction site traffic management, maintenance, and the like for many years now. Currently program manager of maintenance at the Department of Transport for Victoria. and has worked on a variety of Austroads committees, Australian Standard committees, worked internationally in construction site safety and auditing of construction sites. And we asked Tony to come along because, first of all, he's super knowledgeable, and second of all, he's super passionate, and that's what we like to see in this space. So because he's so passionate and knowledgeable about this, he said, "Oh, great, yep, I'll do 3 days worth of construction site traffic management auditing ideas and things." And we said, "Oh, the course isn't that long, Tony. Maybe you can shorten it down to a little bit."
I'll try, Ken.
We've restricted him to a short sort of 20-minute, 15 to 20-minute presentation here. He couldn't help himself, but he's pre-recorded a longer version, which we've uploaded to Moodle. So people who are in this space should really be watching that and getting some further information. But here's a little sort of summary of the longer presentation, which is a summary of much longer stuff. But over to you, Tony, and thank you very much.
Okay, thanks very much, Ken. And I hope there's not some background noise coming through. Where we've got the wonderful joy of looking after a couple of grandchildren, and one's due for a sleep, and so I hope that's not coming through the background. You're picking that up?
No, well, maybe a little bit of something, but it's all understood, locked down.
Yeah, absolutely. And don't worry, it's a great part of our day when they come and arrive. So it's all good. All right. Thanks very much, Ken, and welcome everybody. And thank you for your participation in this, looking at the RSA Road Safety Audit of Construction Sites. So, and I think Ken's probably covered off my history in this area. Been with, I think the slide's 12 months old now. I'm getting up to 39 years with the Vic Roads Department of Transport, and predominantly in the road construction and road maintenance area. As Ken mentioned, I've been fortunate enough to be on a couple of international projects in Dubai, Philippines, and Indonesia. So, and again, looking at, work site safety at roadworks. I've, trained traffic controllers, traffic management implementation, and of course, this road safety auditing side of things. So, and I'm currently the program manager of maintenance across regional roads, Victoria. So a statewide role that certainly keeps me busy between the hours of 8 and whatever time the day ends. So it's been a good journey. It's been a wonderful journey, and it continues on. Just want to draw your attention, and I suppose it's all about auditing and understanding the environment you're working in and how you perceive something. And as auditors, there's an expectation that we look outside the square, we look out beyond our, and it's the reason why we as auditors shouldn't do a road safety audit on our own project. If I was, managing a construction site, I could do a compliance audit, but I shouldn't do a road safety audit, because I could be focused on the project in hand rather than looking at the full picture. And I think that's really an important part of being a road safety auditor, is that you have that fresh set of eyes. You're able to go in there without any really perceived expectations of what you're going to find, and you understand and have a look at the site for its face value and what you see from the safety point of view. And this is actually just a car park at our Warrnambool office. It's got dots down to indicate where vehicles are to park. Is it 45? Is it 90? And this is, I've worked out of that office for 30 plus years, and I've always thought, that's not confusing. But is it, as I said, is it 45 or is it 90? And one customer thought it was 45, another one said, no, it's 90. And these are we need to be mindful of how we set things out. This is a very simplistic example, but if it comes to, we're trying to protect people's lives and making sure that here we go. Sorry, people, I need to, where's Grandma? Give me 2 seconds, please. This is a joy of.
I'm going to just take over for a second and talk a little bit about. I'm going to talk a little bit about.
Sorry.
No, you're good to go. I was going to jump in.
Yeah, no, all good.
Talk
all
a little
good.
bit about the prompt list, but
yeah, so
you're back to it.
And so we just, it's the picture we see and what we perceive and what we're trying to sell to the public and the workers to make sure our sites are safe. So as I said, it was a very simplistic view of it, but it can become confusing if we don't do it right. And this is the role of the road safety auditor, to make sure that those safety components have been addressed and we look at the whole site rather than just a few signs. And this is what this next slide is talking about. A road safety audit. It's not a compliance audit. While we have codes and standards we must follow, we have a traffic management plan. And while I'm just talking about this, Emma, if we could look at maybe asking a question, do people know the difference between a traffic management plan and a traffic guidance scheme? We hear TMP and TGS used all the time when we talk about traffic management at roadworks. Are we able to differentiate between those two? So I'll continue on and we'll see if we get some answers. So so the traffic, as a road safety auditor, yes, we've got these Australian standards, we've got these Austroads guides, we've got the traffic management plan that must be followed. But as a road safety auditor, we look beyond that. We look at the safety issues that could be compromised if the site hasn't been set up correctly. As I mentioned, we now have an Austroads guides, and these are basically introduced right across Australia now and in New Zealand. I'm not sure of the uptake across all the jurisdictions. I know WA, Queensland have taken them on board. Vic Roads or Victoria is taking them on board. We haven't, officially introduced them yet, but they will be. And I'm not too sure what's happening in NZ either, whether they've implemented them just as yet. But as on the slide, there's copies of these on your USBs, but also Austroads are going to update these on a semi-regular basis. So, we've got up-to-date information on how to manage traffic at roadworks. And, it's fairly comprehensive parts, but, it's a really good way that we can help manage and understand the process. And we've got all these parts to support the way we are to manage our roadworks using the signing and the like. How do we go with the question? Anybody get an answer through to us?
We do have some responses, Tony. We've got Damien said TGS is a guide and TMP must be followed. That's the response.
Yeah, I'll let that one go through, even nearly, but not quite.
Okay, well, we have another one from Russell. We have management plan, justification and decision-making process that goes into the guidance scheme, which shows the layout of signs and management system.
I like that. That's well put. Yes, and that's correct. The traffic management plan is the overarching document, or overall, it'll have, what are the bus times? What are the peak hour times? What are the traffic volumes? What are the emergency contact numbers? It gives you that full information about the site. And from that traffic management plan, we will then have a series of traffic guidance schemes, whether it be when we're doing the earthworks, it may be when we're doing the pavement works, when we're doing the drainage works. We might have a series of these guides as well as after hour work. So yes, the plan is how are we going to manage it all, and the guidance schemes are the layouts basically. So yeah, good answer. We'll give that person a medal. I'm not too sure bronze, gold or silver, but we'll keep on working that way. Great stuff.
give him a prize. And just another comment as well from Catherine. She said, we're having an update at the COP-TTM in New Zealand. So that's interesting.
Yes, so correct. So, and that'll be based on these Austroads guides, because we had all the jurisdictions across Austroads, including a rep from New Zealand at our committee meetings. And yeah, so that's the intent, that they will, these guides will be taken up by all jurisdictions. That's good to hear. Thank you. And look, and this is just another example of where we get it really wrong. And you know, this was a job that was being looked after by Powercore on the Hamilton Highway near Geelong. And unfortunately, the crew that was managing this site didn't have enough signs to cover up the 100k an hour. They come up with the excuse that, oh, if we put the 40 near the 100, traffic will obey the 40. That's not going to happen, unfortunately. We're trying to protect the workers by using the 40s. There's a reason why we've got 40, is because there's workers present and they're close to the through traffic. So therefore, we need to ensure that it is installed correctly for that to happen. And if you come across that situation, it's not going to happen. People are going to be confused. They'll say, what's going on? Throw their hands in the air. And unfortunately, they won't comply with the signage. So, and while this is a compliance issue, it also is a safety issue, because the workers' safety could be compromised because of the way this has been set up. So it's really important that, yes, we've got these set standards and codes we must follow, but we've got to look at the safety side of things and the effectiveness of the signs. Now, if that was reduced to 40 kilometres an hour and the signing was set up correctly, but traffic weren't complying with that speed requirement, there's a reason why. We can't just rely on a sign telling us to slow down, that there's workers or traffic controllers. We may need to introduce other devices. We may need to do narrowing. We may need to just put up extra bollards or cones just to give that visibility that there's a presence of something to force the traffic to slow down. As I said, a sign will not ensure that we slow down. It's the lowest part of the hierarchy of control. And you know, I'm sure people through their OHS training have talked about the hierarchy of control. You know, at the top end, we should try and eliminate the hazard. At the bottom end is administrative, and that's what this is. It's just administrative control. We're relying on the other party to follow our signs. We need to introduce ways of controlling traffic to ensure we keep the safety of the workers and the travelling public. I'll throw this one out again, Emma, to the group. What is the best way to ensure worker safety? What do we implement to ensure worker safety is optimised when we want to do a bit of work on a particular road? So if we were on this particular road, if we wanted to, undertake some pavement works, what would be the best way to, working through the hierarchy of control, manage this site?
Well, lots of answers coming through, Tony. Someone said,
yes,
we want to increase visibility, perhaps some bollards or barriers.
Yep, like it.
Separation of traffic and workers. Like it. A temporary barrier.
Yep.
Best option is to close the road. And a detour, lots of detours coming through and closures. Yeah.
And look, that's really encouraging to hear that from the group, Emma, that people are thinking of other ways. And the hierarchy is engineering controls. We have that separate. We have that remove the hazard, detours. Yes. Then we have engineering controls. So barriers, temporary barriers, and we're really moving along in that space with temporary barriers. It's rather costly, but we can have short-term works where we can install some barriers that for that worker protection, we get that separation. And these are the type of things we should be looking to ensure we get that separation of the traffic to the workers. Yeah, great answers. Thanks, everyone. So why are we doing all this? I'll just put them all up on screen, too many. Okay, why do we undertake this road safety audit at construction sites? And Emma, please give me a 5-minute warning too. I could ramble on, as Ken said, so just give me a bit of heads up. Thank you very much. So we typically involve a change of speed. Traffic arrangements during road can be changed several times, and can bear no resemblance to the permanent arrangement. And that was sort of that original slides I had. And I spoke about Jamie's slide where he did that drawing. When we change the conditions, people can become confused, and unless we sign it accordingly with our signs and devices, people can become disorientated. They travel the same road every day. I go through here at 8:30 so I can get to the office at 9:30, whatever it might be. All of a sudden you chuck all these different devices and lane closures or whatever it might be at me. We need to ensure that the safety's not being compromised. And again, I'll go back to, as road safety auditors, we can make sure the signs are correct, but is it giving the correct message? Is it making sure that people can get through the site safely? And are we ensuring the safety of the workers? Very important. The construction contractors may not appreciate the finer points of traffic management. And that, again, I'll harp on, as a road safety auditor, that's where our role is to help assist in that way. We make sure that their standards arrangement are applied for consistency. If you go through a work site, whether it be in New Zealand, New South Wales, or wherever it might be, we are looking at those same consistencies and types of messages. To avoid conflicting messages, our permanent and our temporary devices, we need to ensure that if there's a conflicting, they're either covered up, removed, or whatever it might be. To check signs are used for their correct purposes. Far too often, you just see a workman symbolic left up 24/7. It should only be installed when workers are on site. Sometimes it's laziness of the traffic management company or the contractor. Sometimes it's actually a lack of knowledge of what that sign is meant to do. So again, as auditors, we need to ensure we're pushing the right message so we can get that safety component worked out and a consistency worked out. We need to provide safety for all personnel and the travelling public, as I've mentioned, and the connection of any crossing points for the traffic and the public, that they are safe also. We have those haul roads or might be managed where the construction traffic have to cross the normal roadway. Make sure that those crossing points are managed accordingly. And the other big one in some of these is the queue build-up. If we have portable traffic signals or even traffic controllers on site, that we have traffic stop for a certain period, the queue length might get beyond our signs. We need to monitor that to ensure that our warning signs are appropriate for the length of queues. And now that I've mentioned traffic controllers, there's a real push in the industry to remove traffic controllers from the side of the road. We're not saying to remove traffic controllers. They are an important part of managing traffic flows, but to get them off the side of the road, that they could use remote control temporary traffic signals, that they use remote control type stop slow bats. There's a lot going on in the industry at this space. So, I think it's important that we keep up with that technology to ensure we continually make our site safe for our workers. And the other side of it, a very probably, quick task that this bit of pavement was probably, or side footpath was deformed. And so the managing authority thought, well, yeah, we need to replace this. This was at the end of the day. It's in Geelong. I was, staying down there and wanted to get up to grab a bit of food up in that top street. And it was okay for an able-bodied person, but if you were visually impaired or required some help to get around, whether it be a scooter or a walking frame or a like, that your options are now being taken away from you. The planning for that has really forgotten about all users on this particular road, or footpath. So, it's really important that we look after everybody, all the road users' interest to ensure the safety. Signing. Most of our roadwork signing is black writing on a yellow background. This is a regulatory system with the traffic signals. It's a regulatory sign that should be there, stop here on red signal. So it should be red writing on a white background. But, a sign manufacturer thought, well, all roadwork signing is black on yellow. Let's use that. It's not correct. These are just the little things. And while it may not have a direct influence on the safety, it could have a direct influence if people were continually disobeying the red traffic signal. We may get law enforcement involved. That would not hold up in court if it was challenged because it's the wrong signing. So, that's important why we need to use the correct signing associated with the message we're trying to portray. Very quick one for the group here, Emma, that we've got 2 stop signs here, and the difference is certainly by shape. What are each of these stop signs used for, or what's the difference apart from shape between these 2 stop signs? And people who've done their traffic management training probably should pick this one up.
Yeah, we're getting some. So the right is for construction. Oh.
Okay.
And one is temporary, one is permanent. Traffic controller is round.
Yep. Happy with all that. But there's a real stark difference between, yes, we must stop. Any others come through?
And temporary and permanent. Right is a lollipop sign and the left is a standard road sign.
Yep. Look, people are right, but there is one real difference, is that the one on the round one, while it's displayed in the driver's direction, the driver must stop and not proceed beyond that point unless directed otherwise to do so. The octagonal one they're correct. It's at our permanent sites, but the driver makes the decision. They stop. If it's clear and safe to proceed, they can proceed. So, I have seen it where they've used the octagonal one for traffic control, and a member of a driver could proceed if they look up the road and think, well, there's nothing coming, I can proceed. That's the incorrect use of that sign there. So that is the difference between those 2 signs. So well done. And that's an actual photograph. So we're not making the site as safe as it should be by using that sign. There we go. And just looking at that photograph, the traffic controller is certainly has their fluorescent safety gear on. There's separation of the work site with the bollards. It looks as if, and hopefully that the traffic has stopped, and that's why the traffic controller can step out onto the road. Otherwise, if they're not controlling traffic with a vehicle stop, they should be back off to the side. Unfortunately, you see that too often where the traffic controller does not get off the road when they're letting traffic or releasing traffic. So when to audit? It's certainly a role that we can undertake at many phases within a construction program or site. And it's certainly early at the beginning of a construction job. We can even do that before the job begins. We can do a desktop review of the guidance scheme, the plans and the guidance scheme, to make sure that the auditor, they would visit the site, they would see the traffic management plan with the traffic guidance schemes within that. and they could say, yeah, look, I think that suits the situation. But then when the construction begins, that's when you should go out on site both day and night, review how the signing has been installed to make sure all the safety components are being looked at. Nighttime is one of the biggest areas of concern when undertaking, when we have traffic management in place for construction, because we just get that different viewing of the site, whether it's well lit, are the signs retro-reflective, are they clean, are they portraying the message we need to, is there loose material, do we need to manage that loose material that, at the end of the day, should we've been able to just, grade off that loose material, could we just put the roller on it a few more times rather than, dumping our last load a couple of minutes before we knocked off. It's just making sure the site's been managed to make sure the site is certainly being looked after. And I just like that slide too, that, inspect the site day and night, inspect the site day and night. It's an important part of when undertaking a road safety audit, whether it be construction site or whether it be at a design stage or any road safety audit, make sure you do both a day and night inspection, because you need to understand that the different driving conditions give us a different perspective of what we're looking at. So some of the common issues we come across, adequacy of the advance warning. It's really important that we know that the drivers and the people using our network, they have been given advance warning. The speed limit, have they been correctly installed? Are they, and I'll put a question out there around this too, Emma, now. What is an important part about if we reduce the speed, what other signage must we install to ensure that that speed limit is managed correctly? I hope I haven't confused the question, and I'll see what answers we get.
We're getting it. We've got an answer in. We've got a reduced speed ahead.
Yep.
Roadwork signs.
Yep.
Change.
The other end of the job. Is there anybody mentioned the other end of the job?
I've got change traffic conditions. When to return to normal speed.
Yes. Yes. Yeah, that's, maybe I didn't put the question together real well, but that's an important part of we reduce the speed, we're looking after the worker safety, we're looking after the travelling public safety, but when we're at the end of the job, we must put up the return speed, the prevailing speed. Again, far too often we see that isn't installed, and compliance then is being compromised. Again, some common issues, the appropriateness of the selected standard layout. Again, the conflicts between the permanent and temporary features, any aspects of the layout or devices that could be misread by drivers. Line marking is a really common one where we black out line marking to so that for the construction works, but it wears off, or sometimes they only use black paint, and at night time or when it's wet, that can reflect back up. And then again, arrows might be misleading, or the barrier lines could be misleading. It's really important that you do look out for those types of things in your nighttime inspections, that, those line markings, are they being effective on what we're trying to achieve? And certainly mud and dust, and this time of the year, there's a lot of mud about, and especially in the summertime, the dust does obscure our devices, our bollards and alike. So, make sure that they are effective, especially for their nighttime use. The appropriateness of traffic barriers, have they been installed to the manufacturer's specification? Ask that question, and don't just say, get the answer, oh yeah, it has. Get some evidence to see that they have done that, because there's so many different types of barriers around. Ken might chime in and tell me what the name of the document is where all the approved barriers are kept. I know that document is updated on a regular basis. So it's important that, we understand what barriers can be used, but have they been installed correctly? Has the vision for pedestrians, cyclists, that they are big users of our network, and are we ensuring that we can manage the site to make it safe for the cyclists to get through? Conflict points between the works traffic and the general public, make sure that is managed accordingly. Ken, you've come on board.
Oh, I was just going to say, it's Road Design Note 0604 in Victoria.
Yep.
Which lists all the accepted for use barrier products, and then each jurisdiction has their own list. So you've got to check your jurisdiction's website. So Principal for New South Wales or NZTA or the like, depending on where you are.
Thanks, Ken. Yeah, and I suppose it is important that we do keep up to date with publications to ensure that, yes, we are continue to check on the right things and check to make sure things are being complied with. The last thing, and Ken will go into a bit more detail on this one, is the checklists. And, there's a myriad of these checklists depending on what type of audit you're undertaking. But, some of the detail here, and these are used as more as prompters rather than this isn't the be all and end all of what you should be checking, but it's prompters for you to understand what I should be looking for when I'm undertaking a road safety audit. The alignment, your turning radii, your traffic lanes and your visibility, nighttime, worksite, speed management, delineation. I'm going through these fairly quickly, but these are the type of things that you need to be looking at. But I'm sure there are other matters when you get to site. You think, well, is the overhanging trees, are they causing any issue? Is the, in the middle of the day, is the traffic controller being hidden by the shadow of these trees, or whatever it might be? That yes, there are other items on a site that could cause you concern with the safety of the site. So have that open mind and have this one in your back pocket, but rely on your skill and ability and understanding of the process to prompt you in looking out for those safety issues. I think that'll do me, Ken.
Beautifully done, Tony. Thank you very much. And as I mentioned at the start, there is lots more Tony in Moodle with a longer video. And of course, if you did want to follow up and ask a question to Tony, if there was something that you wanted to elaborate on, we can put you in contact with Tony, and his contact details are at the front of the slides you got. I'll just pause, check if there's any final questions, but thank you very much, Tony. It's an excellent sort of high-level summary there, and each of those points could have gone into a lot of detail.
No questions there, Ken?
No. So thanks, Tony. Thank you very much. Enjoy some time with the grandkids. And
I apologise for that, Ken. But that's the joy of working from home. And it's a couple of days a week. My wife has the kids, and of course they like to come up and see Pa every now and then, and the opportune time.
That's it. And do they make an appearance in the video, or you talk about their perceptions of some of the traffic guidance schemes?
Yeah, it was our eldest granddaughter just doing a drawing. I had some of my training signs and whatnot, and she had the perception of the signs must go on both sides of the road when you're reducing the speed. I don't know whether it was by chance or whether she has heard me talk about it, but it was really interesting that an 8-year-old had that perception of doing the right thing. So it was, it was really wonderful.
It's great. All right, thanks, Tony. Thank you very much. Have a wonderful day, and I'll keep ticking along and actually take over from where you just left off with checklists.
Thanks, Ken. Thanks, Emma. Thanks, everybody. Enjoy.
Thanks, Tony.
Okay. All right. Let's think somebody's going to give Tony a call a little bit later and have a bit of a chat about something. That's good. Please do that. Right. I just want to take a little bit of time to talk about checklists. It's not going to be long because I just want to do two things. Point out that there are these checklists available in the Austroads Guide to Road Safety Part 6A, which is in Moodle. We've uploaded there in the resources. It's on your memory stick. These checklists are, as you can see on the page there, separated into feasibility, preliminary, detailed, pre-opening. And some of them get up to sort of 10 pages worth of questions and prompts and things for you to think about as you're auditing. You do not hand this in with your audit. They are thought starters. They're things for you to use to help your process. Thought starters only. You need to stand back and look broadly at the project, the scheme, the design, the traffic management, construction, whatever it is, just as Tony was saying there. And there'll be plenty of things in there that you write not applicable, because these are trying to cover off all road scenarios. It might be asking about, entry ramps to a freeway or something, where you're going, well, I'm doing a local road. That makes no sense. Yeah, that you're at least sort of working through all of these, and you don't submit them. So when you come to do your actual road safety audit, we will be suggesting strongly that you utilize the preliminary design checklist. The preliminary design one is probably the good one for the exercise you'll be doing. None of you are getting detailed designs, because there's just too much time and effort in a detailed design. Preliminary design's a pretty good one. Feasibility could be the go, but I'd suggest you get that, you have a look at it, you read through those questions, and it'll guide you to some findings. It'll help you. It'll make your assignment much easier. So before we get you out there doing the actual audit of a real design in your local area, looking at a site, so we're going to prime you up for that in the next module. This one, which is a much quicker exercise, just to get you familiar with the writing up of an audit. We're getting you to do this little desktop exercise, and it's all housed within Moodle, and we'll show you that shortly about how you're going to do that. But the design you are being given to look at just at a desktop level, and remember, this is a real audit. You can't do a desktop road safety audit. They can do a desktop review, a safety check, a design review, all of that, absolutely. But the audit involves that site visit, the inspection, and it's a broader thing. But this sort of desktop review audit style thing as a practice, a training exercise, you're looking at this design, which you'll get, and you've got a copy of it. The blue lines are the proposed. The grey underneath is the existing conditions. And so the proposal here, it's Victoria Parade and Wellington Street in the sort of East Melbourne, Abbotsford, Collingwood sort of area. And it's actually built now. Some of you probably know it, but you're looking at it at the design stage. So you're pretending it hasn't been built. This is a big wide median here. And then this is a tram, a light rail running through the middle. And they're trying to reconfigure it so that it has this dedicated bike facility here, which is curbside bike. Over this side, curbside bikes, no parking. This side, the parking's been pushed out into the roadway, as opposed to the bikes running along next to the driver's side doors, and they've been pushed out. So a Copenhagen style lane. And it's being proposed there, and they're changing some lane configurations, lane widths, adding in some local area traffic management features, putting some bike boxes. That's the bike box Jamie was talking about, bike storage box there. So, as the cyclists all come along here, they can store here, congregate, and off they go. Your job is to look at this and to then follow the instructions in Moodle. Okay, And it's all about practicing. I'm not going to go through the details of it. It's all about practicing the wording of findings. That's the key part. How do you word a finding? How do you risk rate it? And how do you make recommendations and categorize those recommendations? This is all stuff that I covered in module 1, if you want to go back and watch the video or look at the slides. But I think the act of doing this in Moodle will help you get your head around what we expect to see out of an audit finding. Now, remember, you have 3 attempts at this, so you can have a go at it and you'll probably pick up and understand a few things a bit better, and then you might want to have another go at it. You've got to get that 80%. If you really have just completely can't understand the whole thing, get in contact. So this is the current situation, parking out here, and what's going to happen is the parking will get pushed out here and the bikes will be going down there. I'm going to stop showing that because there's a few pictures from the site in your slides, but you don't need to really do that because Moodle is going to walk you through all of these. So I'm just going to share my screen again and just show you, sorry. Actually, looks like there's a Wally there. I better do this just so your Wally count is right. There's a Wally and 2 pictures of the site. I did remember. This is what it's going to look like when it's built. That's what they're trying to build, and that's on the other side. And I'll leave that there for a second because there's a little bit of a tricky little Wally there. But your aim is to try to, from a design perspective, is to try to identify issues, but we've helped you out here. So when you go to Moodle and you go to RSA desktop assignment test, so you've got a quiz to do as well, just like every other module, just your usual questions, but this one's a little assignment. And then you click on that. I have to do it as a preview, I think. Yeah, so it's a little bit small to see, but you just have to do some filling in of the gaps of words that are missing. And you drag those from the options below. So it takes a little bit of thinking about, oh, okay, what's the site? You got to look at the plans, get your head around that, but then you just drag and drop into the one you think it might be. So have a read of them, look at the plans, find the issue that's being talked about, but also take note of how it's being written. Remember that recipe, that formula we had? What's the issue? What's the crash that could happen? What are any factors that may increase the risk? And other, if there are any standards or guidelines that back that up. Then you'll be asked to, how do you risk rate this? Well, this one in Moodle here, we're saying that the auditors are predicting that the crash finding will occur occasionally and the outcome will be serious. So what is the level of risk? And so remember, that one goes back to your risk matrix. You're going to have to find the risk matrix and then work out occasional is the frequency, serious is the severity, what is the resulting risk? And then the next question, head-on crash between passenger vehicles. So you've got the speed and you've got the crash type, 30 to 50. And then it's just simply asking, is that within safe system tolerable energy levels or above safe system tolerable energy levels? So again, out of module 1, your slides, there are set figures on what sort of this tolerable energy and non-tolerable energy. And you've got to say, right, okay, it's that crash type, it's at that speed, is what they're predicting is going to happen. Where does that lie in the tolerable, non-tolerable? And then the recommendation is put forward, alter the line marking, and then you have to decide, is that a primary safe system solution, a supporting safe system solution, or a non-safe system solution. And those are defined in the Austroads Guide to Road Safety Part 6. I've put them into Module 1, but primary has to virtually eliminate the potential for that crash to happen, even with humans being humans. So it's really not the possibility of that crash resulting in death or serious injury, or the possibility of it at all. So anything like line marking, signal changes, anything like that is going to be a supporting treatment, because it's relying on the humans making the right call based on what they see and making sure they're always, alert the whole time and these sorts of things. Physical things that block off or slow people down, they're more in your primary solutions and the like. So have a read back of that to try to get your head around it. This one, you might struggle a little bit with the start, but you'll get a bit of practice. So you've got a few of these to go through, so you go to next page, but I've just taken you through that now to help you out there. Any questions about what you have to do? So quick quiz and this little assignment, all housed in Moodle, and then you'll be primed and ready to go, because you'll know how a finding should be written up. You'll know how to risk rate things. You'll know how to think about the safe system energy tolerance levels, the biomechanical physical force that human can handle in those crash types, and whether it's above that or below that. You'll know how to categorize recommendations into primary or supporting, and you'll be ready to find your design and find your site, find the audit template we're going to give you, and get out there and do a bit of auditing. But that's you'll get a full briefing on that on Friday. Anything to add, Emma?
I just wanted to let people know, if you're looking for your desktop audit design, it's the second item under Module 3. So it is there under everything for this is under Module 3 in Moodle.
Thank you. So the design is there. You can look at it, and you can download that. Have a look at what they're planning to build. And as I say, they've actually built it, but we are pretending for the purposes of training that you're looking at it at design stage and trying to make recommendations around how to improve things. And you just follow through Moodle. We've sort of segmented it up nicely for you. Any other final questions, or do we give you a few minutes to knock all of that off?
Sounds like a plan.
They're all excited to get into it. Thank you, Emma.
Thanks, Ken.
And we'll see you all on Friday.
See you Friday.